Rainbows usually look about how you'd expect, but there are many different types of rainbows, and some of them are unbelievable. Here are the top 15 most amazing rainbows. Number 15. Contrails. We've all seen contrails left behind airplanes as they fly at high altitude, but rather than being some form of weather control like conspiracy theorists may have you believe, they are harmless trails of water vapor that condense in the atmosphere after being released through combustion in a jet's engine. Usually, this water quickly turns to ice because of the freezing temperatures, which is why they can appear to be like small linear clouds, and the water behaves just like any other vapor does. If you catch it at just the right angle on a sunny day, the contrail being left behind a plane will refract the sun's rays in exactly the same way as it does when it rains. And this can lead to the formation of unusual rainbows that are contained solely within the radius of the trail. The larger the plane, the more pronounced this effect will be, and it's one of the most spectacular sights you'll see during a flight if you're lucky enough. Number 14. Moonbow. Rainbows are formed when light from the sun is refracted by high levels of moisture in the air. But it's not just the sun that can cause them. The light from the moon can create them too. Moonbows are far rarer though, because they only happen at night when the moon's glow is at its brightest, and tend to be weaker than rainbows because the light of the moon in the sky is nowhere near as bright as what is emitted by the sun. This lower intensity means that even if you're lucky enough to see a moonbow, you probably won't be able to see all the colors you do as a typical solar rainbow, and it will instead appear to be a white arc across the sky. The refracted colors are there though, and long exposure cameras are able to capture them in their full glory. Rather than seeing them during rainstorms, the most common places to witness a moonbow is where there's a lot of mist in the air. The Niagara Falls is a great location to see them, as are the cloud forests of Costa Rica. Number 13. Upside down rainbow. Normally rainbows form with the arc facing upwards, and the ends appearing to make contact with the ground. But there's one type that forms in the completely opposite orientation and is known as a circumzenithal arc. Looking almost like a multicolored smile in the sky, this phenomenon is caused by sunlight refracting through ice crystals in cirrus or cirrostratus clouds, and is one of the most vivid types of sun halo. Within the clouds, the ice crystals have to all have the same orientation that create a 90-degree prism effect from where the sunlight enters. They therefore can't form in areas of high turbulence, and because of the angles involved, can only happen when the sun is at an altitude lower than 32.2 degrees. Surprisingly, they aren't particularly rare, but they can be difficult to see because they form so high up in the sky. Conditions have to be just right to be able to spot them from the ground. But if you see other light effects taking place, the chances are that an upside-down rainbow will be forming somewhere nearby too. Number 12. Full circle rainbow. Most rainbows are created when sunlight passes through water droplets in the sky, which in turn refracts the light into its constituent colors. The most common type form an arc that reaches up into the sky, but surprisingly, instead of forming a half circle, all rainbows are completely circular. The problem is that we aren't able to see the entire thing because the bottom part of the circle is cut off by the horizon. The size of the rainbow that we see is directly affected by two main factors: the position of the sun and the height from where you're looking at it. The lower the sun is in the sky, the higher the rainbow's arc will be, and the higher that you're looking at it from, the further you're able to see into the horizon, so the more complete a rainbow you'll spot. People at the top of mountains will see something very close to a full circle rainbow, but even then they aren't high enough. It's only really pilots with their wide windows and the occasional lucky passenger who'll see the full circle of color, and even this is a rare occurrence. Number 11. Reflection rainbow. While rainbows may seem like optical illusions, the bands of color do actually exist and can behave in a way as any other light source. This can lead to a number of unusual phenomena, the strangest of which is a reflection rainbow. For one of these to form, very precise conditions are needed. First, the rainbow needs to develop over a region of water, and this water needs to be perfectly calm and still. When the sunlight is powerful enough, it will reflect back off the surface of the water and be refracted through water droplets in the same way as happens with a normal rainbow. But because it's traveling at an altered angle, this new rainbow will be a completely different shape and size to the primary rainbow that has been formed. There's only a few places in the world where the geography is right for this to happen, and the best place to see a reflection rainbow is the Scottish Western Isles. Here, the prevailing storms that pass over from the Atlantic bring a fine mist that's ideal for rainbow formation, and the numerous bays and inlets provide an ample opportunity for this reflection effect to occur. Number 10. Monochrome rainbow. Rainbows are known for splitting white light into its constituent parts and creating a dazzling display of different colors. But it doesn't always work like that. When the sun is particularly close to the horizon, for example, a rainbow can form that only has one color, something that's known as a monochrome rainbow. The low angle of the sun means that the light has to pass a much greater distance through the atmosphere and results in shorter wavelength light, such as blue, green, and yellow, to be scattered and dispersed. All that remains in this scenario are the longest wavelengths, which are red, which creates a deep crimson-colored rainbow. And this also happens early in the morning or late at night when the sky is darkening. The contrast of the red against the twilight sky can be incredible to see. It's a fairly rare phenomenon to witness because conditions for a monochrome rainbow have to be absolutely perfect. But if you're lucky enough to be in the right place at the right time, it's something you'll never forget. Number 9. Fog bow. Fog bows, which are often called white rainbows, are formed along the same principle as colored rainbows, in that they occur when the sun's light passes through water droplets in the air. But, as the name implies, instead of being refracted by rain, the light is instead passing through fog. This has a big impact in regards to the arc that's formed, because the water droplets in fog are a fraction of the size of raindrops, in some cases no more than 1/500th of an inch in diameter. The colors of a fog rainbow are therefore very weak and almost impossible to determine by the human eye. Instead, they re-emerge to create white light, which is why the arc looks this color. But you may see a red tinge on the outer edges and a blue one on the inner edge of the bow. They are often seen at sea, and when this happens, they are traditionally called sea dogs, and they can also be seen at altitude when they're known as cloud bows. The light from the moon can also cause this effect, and on the rare occasions that one of these forms, it's known as a lunar fog bow. We are constantly adding more people to the Top 5's production team to bring you all the best content. Be sure to subscribe with notifications on and hit the like button. Number 8. Double rainbow. When rainbows form, it's often a relaxing and stunning moment to look up at the sky and take in the colors. But sometimes you might be treated with 2 bows for the price of 1. Primary rainbows are caused by the sun's light refracting through a raindrop, but amazingly, when the sun is lower in the sky, this can happen more than once in each raindrop and leads to the formation of a second rainbow, or even more. When this happens, the second rainbow appears in the sky about 10 degrees above the primary rainbow, and you'll also notice that the colors appear in a different order. This is because the light is being split in each raindrop and sent in a different direction. The violet light that you see in the second rainbow is being reflected towards your eyes by the higher up raindrops, and the red light is coming from the lower down ones, whereas this is the opposite in the primary rainbow. Number 7. Rainbow wheels. Because of the way they form, the center of a rainbow is also the anti-solar point. In other words, it's the opposite side of the sky to where the sun is. There are several other phenomena that can occur in this region of the sky, and when they combine with a rainbow can look very unusual. If there's a particularly large storm taking place, the clouds will cast shadows across the sky, which, due to perspective, will seem to converge upon the anti-solar point. If these clouds just so happen to be within the cone of a rainbow's formation, they'll create shadows that prevent certain parts of the rainbow's light from reaching your eyes. This can result in dark radial spokes reaching out from the anti-solar point and cutting gaps in the rainbow, which looks very similar to the spokes of a wagon wheel. This causes what's known as a rainbow wheel, and if conditions are right, things can get even stranger. If the clouds are moving across the sky and their shadows are moving in the right direction, the spokes will actually appear to be moving, which in turn will create the illusion that the rainbow is rotating in the sky just like a wheel. Number 6. Waterfall rainbow. Any place that water is suspended as particles in the air has the potential to form a rainbow, and some of the most amazing you'll ever see happen within the spray of a waterfall. Here, millions of gallons of water can crash down onto the river below and throw up a huge region of small water droplets that are ideal for refracting the sun's light. If you're looking directly at a waterfall, then you'll need the sun to be directly behind you for a rainbow to form. Some of the largest waterfalls in the world, such as the Niagara Falls and the Victoria Falls, are also the best places to see this effect. And if you can catch it at just the right time, the rainbow can extend across the full width. The same thing can also happen at nighttime if the moon is shining brightly and is in the correct position, which means that waterfalls are often your best chance of seeing a moonbow, and you're far more likely to see one there than through a rain cloud. Number 5. Alexander's Dark Band. When you see a double rainbow, or even one with more than 2 arcs, you may notice that the sky between the two appears to be a lot darker than elsewhere. This is a phenomenon known as Alexander's Dark Band, after Alexander of Aphrodisias became the first person to document the site in the year 200 AD. The reason why this happens is because of the way in which the light is being reflected and refracted to form the rainbows in the first place. The formation of the primary rainbow, light rays are undergoing a single refraction from the arc and brighten the region of sky within it. In the case of the second rainbow, the light inside the water droplets is being reflected twice, and so they form the double bow and brighten the sky outside of it. This leaves the region in between the two bows where there's no extra light being reflected back at all, and this is why it appears darker. In fact, this is the natural brightness of the sky, and it's the region inside the primary bow and outside the secondary bow that's being artificially lit up by the way the light is passing through the water droplets. Number 4. Twinned rainbow. Everyone has seen a single rainbow, and most have seen a double or even triple rainbow. And most of us have been lucky enough to see variations of the different types, but there's one type of rainbow that's so rare that very few people have ever been able to witness one: a twinned rainbow. Instead of forming in series with a primary rainbow, a twinned rainbow begins at the same point, but branches off into a separate arc of its own. It's so strange that for a long time, scientists have been unable to explain why they occur. And it was only when graphic designers were trying to recreate weather effects for video games that they came across the solution. Everyone had always assumed that raindrops were spherical in the sky, and this definitely allows for the formation of double rainbows, but can't explain twinned rainbows. What researchers discovered, however, was that raindrops flatten as they fall because of air resistance, and this effect is far more prominent with larger drops than smaller ones. Big raindrops can actually look like burger patties in shape by the time they reach the ground, and this causes light that shines into them to reflect in all sorts of unusual ways, particularly when there are raindrops of different sizes within the same storm. And when this happens, it's possible for the formation of two differently shaped rainbows that originate from the same position. Number 3. Sea spray bow. Sea spray bows can lead to peculiar rainbow effects, especially when there's a storm in the distance which is also creating the right environment for the light to be dispersed. Rainbows occur when the sun is behind you and the water droplets in the air are in front of you, and it's the position of the sun that determines the point around which the rainbow forms. In this image, there are actually 2 different types of rainbow, and their differences are why they don't join up to make a perfect arc. The top rainbow is being formed in the same way as normal, because of a storm in the distance, but the lower one is formed through the spray that's coming from the ocean. Because this water has a much higher salt content, it refracts the light more strongly, which results in a rainbow that has a smaller radius by about 0.8 degrees. Other transparent media can produce even tighter bows, with those formed through glass being around half the size of those formed through pure rainwater. Number 2. Supernumerary rainbow. Sometimes when a rainbow forms, multiple others form directly around it, and when this happens, it's called a supernumerary rainbow. Quite often, this will appear as a vivid primary rainbow with fainter bands both inside and outside of the main arc. Although if you look closely, you'll notice there's always a small gap between them. The color palette of supernumerary rainbows is also different, and instead of the main colors you see in the primary, they'll tend to be pastel shades of pinks, purples, and greens. The reason why they form is due to the size of the water droplets that are suspended in the atmosphere. When they're less than a millimeter across and occur in storms where there are raindrops of varying sizes, the light is reflected in many different ways and directions. Sometimes the colors reinforce each other to make some bands stronger, and sometimes they bounce off each other to form extra bands that are less vivid. It was the existence of supernumerary rainbows that first suggested to physicists that light might be a form of wave instead of a particle, because they realized the only way it was possible is if the waves of light were directly impacting each other. Number 1. Rainbow cloud. Rainbows occur when the sun's light is being split up by moisture in the atmosphere, but it always doesn't happen in a way that forms an arc. Rainbow clouds, which are scientifically known as circumhorizontal arcs, aren't actually technically rainbows, but they still produce a wonderfully colorful effect in the sky. They form in cirrus or cirrostratus clouds when sunlight beams through the ice crystals that are suspended within them. For this to work, the crystals have to be hexagonal or oriented horizontally, which means that the light enters their vertical sides and is reflected out through the base. This causes the light to refract through 90 degrees. It means that the colors are very well defined when they are split. While in theory, it should create a circular halo in the sky, when there are only small fragments of clouds in which the effect occurs, it will only be them that light up, and creates the illusion that they are small segments of a rainbow. Subscribe to Top 5s for more and check out some of our other popular videos.